All right, so homework. This is from Unit 4, Lesson 6, more exponentials, specifically half-life. The decay of a sample of 800 grams of hydrogen can be modeled by the equation h of t equals 800 times 1/2 to the power of t over 12.32 after t years. What is the half-life of hydrogen? This is just referring to the equation and where things are placed. Remember the original equation, or general equation, I should just say, is a times the 1/2 t over h, where a is the initial amount, t is time, h is the half-life. So the half-life is 12.32 years. You're just pulling that from the equation. How can you tell this is a half-life equation? This is exactly the same question that was in our notes. The base is 1/2. The $2,500 currently in your bank account is decreasing continuously at a rate of 5% per year. Okay, it says continuously. It doesn't say compounded continuously. I'm suspecting that's what I'm going to use, but we'll see. Also, obviously the $2,500 is important and the 5% per year. Part A. Use the continuous compound interest formula to write a function that models the amount of money in your bank account after t years. The r value should be negative because it's decreasing. All right, so they are specifying that we're using APERT, continuous compound. They're even giving you a little clue and telling you that r should be negative because it's decreasing. We haven't seen this yet. So let me plug in here. So my initial amount is 2,500 E. My rate is negative 0.05 and then the T. When will only half of your initial deposit be left in your bank account? To the nearest tenth of a year. Okay, well, half of 2,500 is 1,250. And I'm just plugging that into my formula that I just wrote. And I'm solving for t. They want to know when or how long, right? So I'm solving for t, which tells me I'm going to have to use a log because it's an exponent, which means I need to get my base of e alone. So I am dividing both sides by 2,500, and that gives me 1/2. Can you start off right here with this equation? If you recognize that that's what's going to happen, you can. Just like if you recognize when we were doubling that a 2 was going to be there, but if not, that's fine. I'm going to change the order because I don't like this order. So e to the negative 0.05t equals 1/2. Now I'm going to need to use log. I'm going to use the natural log, and remember when I use the natural log, I don't change the order. I'm just inserting a natural log because I know that the natural log of e is 1, and that would make life easier. But whatever I do to one side, I must do to the other. And then I'm going to use the power rule that puts that down in front of a log. So negative 0.05 t, the natural log of e, equals the natural log of 1/2. The natural log of e is 1, so that goes bye-bye. And now I'm going to divide both sides by negative 0.05. And then I'm going to put that in my calculator. And when I do, I get 13.9 years. If you need help with putting that in your calculator, just send me a little message. Okay, part C, write the half-life formula for your bank account. All right, we didn't do this in class. It's not particularly necessary, But now that I do know what the half-life is, so they didn't give me the half-life in the beginning. They just give me the information for a part. But now that I found the half-life, right, because in part B, I found how long it takes to get to half the amount in this instance, and it takes 13.9 years. So that now becomes my half-life, because I went from 2500 to 1250. So now that I know that, I can just write the formula. So A equals A 1/2 T over H. So my initial amount is 2500. The 1/2 stays the same. T is going to be whatever. And my H is 13.9. So there you go. Voila. Okay, question 3 we did in class, parts A and C. So I'm not going to do them again. If you need help on them, please refer to the video from yesterday. But I am going to do part B. It says how many grams are left after 1 year to the nearest hundredth of a gram. So I'm going to use the half-life formula that I came up with in part A. But I'm going to plug in T. Now they want to know for 1 year. Do not put a 1 there because your half-life is in days. So your time also needs to be in days. If you don't do it, you're going to get an answer of like 262 point something, which makes no sense. Because if you're starting with 90 grams, there's no way that you're getting larger, right, to 262. So my time is going to be 365. That is really important that you recognize that whatever time you put above the half-life is the same units of measurement. So then when you just go ahead and put that whole thing in your calculator, to the nearest hundredth, you should get 2.95 grams. Exercise 5. Jessica keeps track of the height of a tree she plants over the first 10 years. It can be modeled by the equation y equals 4.25 plus 10.16 natural log of x plus 1, where x is the number of years since she planted the tree. Okay, that particular equation, we haven't seen that exactly. In the notes, there was one like that kind of with a log in it. It's not an equation that you need to know. It's just the one that Jessica found for you. So we're just going to answer the questions and hopefully we can pull everything from that equation. On average, how many feet did the tree grow each year over the time interval 0 when x is between 0 and 10 to the nearest hundredth? Okay, the wording here, on average, we don't normally see that as much, even though what they're asking we do all the time. This interval though, if I'm thinking it's slope, but this interval right here, that's usually how they ask us to find the slope, the rate of change. Okay, so the reason why I'm, why I think that we're finding the slope is because it says on average, how many feet did the tree grow each year? So we want to look for how it changed from the beginning to year 10, and divide it by that many years, which would be the average, but that's also how you find the slope. So what I did was I put the equation that was given in my y1, and I went to my table and I grabbed my y values. So that is where I got that from. And I hope you remember that slope is the change in y over the change in x. You can put the 1s and the 2s there, but it doesn't really matter. So I'm going to subtract my y's. So 4.25 minus 28.9 0.613 all over 0 minus 10. And when you do that, you should get 2.44, and then that ends up being feet per year. How tall was the tree when she planted it? Well, there are two clues here. The first clue is in the equation, this amount right there. That's the starting amount. But also in my table that I got from my y equals, at time 0, it's 4.25. So okay. How tall was the tree after 8 years to the nearest hundredth of a foot? So, I mean, you already put this in your calculator, so you can just go to your table. I mean, let's make life easy at this point. And when I go to my table, next to my 8, I have 26.574. It says nearest hundredth, so 0.57 feet. D, how many years to the nearest hundredth did it take for the tree to reach a height of 20 feet? Okay, well, X is the number of years. Usually when we find time, it's an exponent, so that is slightly different, but that is one like we did in class today. So I'm going to put my 20 here, and I am going to solve for X because it tells me that the X is years. And let's see what we can do here. So I'm going to try and isolate the X. So I'm going to subtract both sides by 4.25. It's going to give me 15.75. And then I have 10.16 natural log of x plus 1. Now you can't separate the x plus 1 that are attached to the natural log, but you can get rid of that 10.116 because that's 10.16 times the natural log, so that can certainly be separated. And when we divide that, it's going to depend on what kind of number we get. And we do get sort of a crazy decimal. So just for the sake of consistency, I'm going to leave it as a fraction. So I'm going to rewrite the equation with my log on my left. So the natural log of x plus 1 equals 15.75 over 10.16. Okay, so I'm already in log form. Now, so I can't put it in log form, which is what we would normally do when we're solving for time, but it's also not an exponent. We don't really have a way to convert from natural log to exponents. So my only other choice is to change my natural log to a log base e. Now remember, the natural log and log base e, let me just write this as a reminder, the natural log is the same as log base e. Those are the same, so I'm not changing anything. X plus 1 equals, you know what, just for the sake of what we're doing, I am going to change this to a decimal. I am dividing it, 1.5502. How about that? Now, from here, I am now going to make this into an exponent. I'm going to put it in exponential form. So e to the power of 1.5502 equals x plus 1. Now that my log is gone, I can subtract that 1 away. Now remember, you got to keep the e and the exponent together. You can't subtract it from that exponent. So when you put it in your calculator, just be aware of that. Use parentheses. And when you do that, you should get 3.71 years. Well, that was fun, wasn't it? Number 6. Most tornadoes last less than an hour. travel less than 20 miles with maximum wind speeds of 200 miles per hour. The wind speed S in miles per hour near the center of a tornado is related to the distance D in miles the tornado travels by this model. So they gave you this crazy looking equation with log of D, and they want us to sketch the graph from 0 to 20. So I'm going to put this in my y equals. I'm going to get a table of values. All right, so this is what my graph looks like. I labeled both my axes. I went to my table and pulled some points. So yeah, it looks like it's going to reach 200 maybe at some point, but we're only going up to 20 miles. So, all right. On March 18th, 1925, a tornado whose wind speed was about 180 miles per hour struck the Midwest. Use your graph to determine how far the tornado traveled to the nearest mile. We know how to do this without the graph, but when we first started doing stuff like this, we only use the graph. So I am going to, in my Y2, put 180, and it should give me a straight line. And you will see there is a point of intersection, and that is what we're looking for. How do we find the point of intersection? Well, we're going to hit second, calc, and number 5, intersect. It's going to ask you for the first curve. You just want to move it close to the point of intersection because sometimes there's more than one and they want to know what you're talking about. Then you hit enter, and it should give you 17.24 is your x value. And your y value is 180, which is what it should be. So this point here is 17.24, 180. So my distance there, that's pretty good there. So my distance, so the answer is 17 miles because they want to the nearest miles. That is the end of homework 6. If you have any questions, let me know. Otherwise, please move on to the video for lesson 7.